You walk into the far bedroom, tap Netflix, and the spinner just sits there. So you do the sacred dance. You lift the phone over your head. You turn slowly toward the living room, 2 walls away, like a human antenna searching for a satellite. And somehow, holding a small glass rectangle 3 feet higher actually fixes it. That tiny ritual is hiding the whole strange truth about Wi-Fi. And by the end of this, you will know exactly why the far corner dies, and why the microwave is quietly your enemy. Here is the thing nobody tells you. Wi-Fi has no wires and no clear line of sight to your phone. There is a solid brick wall in the way, and that signal is invisible, so you cannot even see what is stopping it. If Wi-Fi worked like light, one wall would kill it instantly, and your whole house would go dark the moment you left the room with the router. But it does not. It leaks through walls, bends around corners, and reaches your bed. And when it fails in weird ways. One corner is fine, one corner is dead, and standing up sometimes saves you. Understanding why turns a frustrating mystery into something you can actually fix. So here is the one mental model that explains everything. Forget wires. Picture your router dropping a stone into a pond, over and over, billions of times a second. Invisible ripples spread out in every direction and flood your entire house. Those ripples are radio waves, the exact same family as visible light, just far too stretched out for your eyes to see. Your phone is a tiny cork floating on the water, and it reads the pattern of the ripples as they wash over it. Walls do not block those ripples cleanly, they just soak up energy from them, like a thick, wet blanket dropped over the pond. The waves still get through, they just arrive weaker on the other side. Everything about Wi-Fi, every dead zone, every dance, comes down to one question. How strong are the ripples when they finally reach your cork? Let me walk you through the actual journey, one step at a time. Your router takes your data, the ones and zeros of a Netflix stream, and shakes an electric current in its antenna incredibly fast. That shaking launches a radio wave into the air, an invisible ripple that oscillates between 2.4 and 5 billion times every single second. That number, the wiggles per second, is the frequency. It is where 2.4 gigahertz and 5 gigahertz come from. That wave spreads out in every direction at the speed of light, flooding your house almost instantly. It does not travel in a neat beam toward your phone. It fills the space, bouncing off the fridge, the ceiling, the metal in your walls, arriving at your phone from several directions at once. Now it hits a wall, and this is the whole ballgame. The wall does not stop the wave, it taxes it. Every material charges a toll. Drywall and wood are cheap, they barely take a cut. Brick and concrete are expensive, they can eat half the energy or more in a single wall. And anything with water or metal, a mirror, a fish tank, a fridge, a person, is a wall of its own, because water is very good at soaking up these exact frequencies. The wave that survives all those tolls finally reaches your phone, but faint. Your phone has a tiny antenna listening for that ripple pattern, and as long as the signal is louder than the background noise, it can read it. This is why 1 bar still streams and 0 bars does not. It is not really distance, it is how much signal survived versus how much noise is drowning it out. Here is the twist that explains the microwave. Your 2.4 gigahertz Wi-Fi sits right next to the frequency a microwave oven uses to heat your soup, about 2.45 gigahertz. That is not a coincidence. Both share the same slice of public airwaves, and water happens to absorb energy in this band, which is exactly what cooks your food. A microwave oven is heavily shielded, but it leaks a little of that energy, and to your Wi-Fi that leak sounds like someone shouting in the same room. Your phone cannot hear the faint router over all that noise. That is real interference, and it is why your video buffers the exact second someone reheats coffee. Now, the crowd problem. You do not have one device, you have a dozen. Your phone, your TV, your laptop, your neighbor's router bleeding through the wall. They all share the same air, and 2 waves arriving at once just garble into noise. So Wi-Fi enforces a rule called listen before you talk. Every device pauses, listens for a clear moment, and only then transmits. If it hears someone else, it waits a tiny random fraction of a second and tries again. It is a polite room where everyone waits their turn to speak. Finally, your phone catches the wave, reads the ripple pattern back into ones and zeros, and checks it for errors. This is also where 5 gigahertz earns its place. Higher frequency ripples carry more data per second, but they are shorter and fade faster, so they die in walls even quicker than 2.4 gigahertz. That is the real trade. 5 gigahertz is fast, but shy. 2.4 gigahertz is slower, but reaches farther. If a piece got scrambled by a wall or a microwave, your phone asks the router to send that piece again. That constant resending is why weak Wi-Fi feels slow instead of just broken. It is not losing your data. It is repeating itself over and over until you finally hear it right. Let me put a real number on how little power we are talking about. Your whole router only sips around 6 watts of electricity, less than a night light. But the actual radio it broadcasts is far tinier than that, often around 1/10 of a watt. It is not blasting a powerful beam through your house. It is whispering. And that whisper has to survive every wall on the way to your bed. Now picture the far bedroom. The living room signal has to cross 2 brick walls to reach you. Each wall might eat half the energy or more. Cross 2 of them, and you are down to a faint fraction of what left the router. Then you lift your phone over your head, and suddenly you clear the top of the couch and the door frame that were casting a shadow, and the ripple reaches your cork a little cleaner. That is the dance. You are not summoning more signal. You are just stepping out of the shadow of a wall. And the microwave in the kitchen, on that same 2.4 gigahertz band, can drown the whole thing out, because its leak can be louder than the gentle tenth of a what your router ever sends. Wi-Fi is not a beam. It is a flood of invisible ripples, and walls do not block them. They just tax them. Your dead corner is simply where too little signal survived the walls. Subscribe to Tech with Joel for the invisible machinery behind the everyday tech you already use, explained fast and made obvious. Now tell me, what is your worst Wi-Fi dead zone? The bathroom, the garage, the back bedroom? And how ridiculous is your signal dance to fix it? Drop it in the comments. And next long form, we follow that same signal off your router and out into the world, tracing the full journey of a single text message from your thumb to your friend's phone across the entire planet. Subscribe to Tech with Joel.